Hello everybody, how are you doing? Nice to see you today. And today I want you to calculate, to consider an example for the topic inverse matrix. So yeah, I think you remember that we got the formula for inverse matrix. It is here. So inverse matrix is a matrix which consists of which can be calculated through this formula. By the way, I didn't say last time that this matrix is known like an adjacent matrix. I use here another one, an adjacent matrix to the matrix A. Okay, let's do one example here. A matrix A equal 2, 1, 3, 4, 2, 2, for example, 1, 2, 3 here. So we have this matrix. The first one step, we have to calculate determinant of this matrix. Determinant A. If we are very lucky and this determinant is zero, we can say that there is no inverse matrix here. And now we have to check it. 2, 1, 3, 4, 2, 2, and 1, 2, 3. I noticed that here we have 2 and 2, and if I take away from the column 1, column 2, I can eliminate these elements. So this determinant equal, I denote like column 2 minus column 3, and I have here the first one column is still the same. 1 minus 3, it is minus 2, 2 minus 2, 0, and 2 minus 3, minus 1. And we have here 3, 2, 3. Okay, now I can see here, if you notice here that we have 2 minus 2 minus 1 and minus 1. So determinant of the matrix A when I add to the column C1 plus C2 gives me 2 plus minus 2, 0, 4 plus 0, 4, 1 plus minus 1, 0, minus 2, 0, minus 1, 3, 2, 3. So now I'm ready to calculate the determinant here, and I move along first column here, the first column here. Next one step, I have to define the signs of the factors. So if I want to express this matrix, or if it is plus, here we have minus, plus, and since that this 0 gives me 0, I have only one term here, and it is minus 4 times, if you remember, I have to take away this row and this column, times determinant of the two matrix, reduced matrix, 2, 3, minus 1, 3. We have two concepts last time, the minors of the matrices and factors of the matrices. And can you notice that when we calculated determinants, we literally calculated the minors of the matrix. And we have here minus 4 times minus 2 times 3 minus 6 minus 3 times minus 1 and we have minus 4, don't forget it, minus 6, minus and minus gives plus 3, minus 4 times minus 3, and we have 12. Unfortunately, it is not 0, so there is an inverse matrix for A. So determinant of the A equal 12. Next one step, we have to define the adjacent matrix, or in other words, we have to calculate the minors of the matrix. So we have 9 elements, so we have to calculate 9 minors and cofactors. Let's calculate firstly A11, and it is minus 1 raised to power 1 plus 1 times M11, and it is minus 1 raised to power 2, it is plus 2, so M11, and it is, we have to reduce this matrix. For the first 2 elements I use this ink because, so 1 1, it is this element, so if I exclude the first row and the first column, I have here just 2 2 2 3. Okay. Next one, A12, minus 1 raised to power 1 plus 2 times M12, and we have here minus 1 minus M12, and it is minus 1 2, the first row, second column, it is 1. So if you cut away the first row and this second column, you have here, I use this red ink, 2 2 1 3. Next one element here, and A13, it is minus 1 raised to power of 1 plus 3 times M13. 1 plus 3, 4, minus 1 raised to even power gives positive 1, so it is M13 here. And if I take away the first row, this third column, I have here 4 2 1 2. And for other elements, we have A21, A22, A23. What else do we have here? A23 here, I'm sorry, A31, A32, and A33. What do we have here? Minus 1 raised to power of 2 plus 1, M21, minus 1 raised to power 2 plus 2, M22, minus 1 raised to power 2 plus 3, M23. So we have here minus M21. If you don't mind, I want to use here green ink, A21. The second row and first column, it is 4, so the rest part of matrix, it is 1 3 2 3. Here we have M22, it is 2. I exclude this, the second row, the second column, and I have 2 3 1 3. A23, I have consequently 1 2 2 1 1 2, And for the last part, 3 minus 1 raised to power 3 plus 1. 3, 1, it is 1 here. The last part of matrix 1, 3, 2, 2. Here we have a3, 2 minus 1 raised to power 3 plus 2. 2, 4, 3, 2. And the last one, here we have 3 by plus 3, 2, 1, 4, 2. And so consequently we have here for the first one situation, 2 times 3 minus 2 times 2, and it is 6 minus 4, it is 2. Here we have minus 4 times 3 minus 1 times 2, and we have here consequently minus 12 minus 2 equal minus 10. Here we have 4 times 2 minus 1 times 2. It is 8 minus 2, 6, minus 1 times 3 minus 2 times 3. We have here 3 minus 6 minus, it is minus 3, it is just 3. Here we have 3, and here we have I dropped here minus, and it is minus 4 minus 1 minus 3. Here we have 3 plus 1, it is 4, so consequently this is the positive number. And we have 2 minus 6, it is 2 minus 6, it is minus 4, and it is minus 4 here. It is 4 minus 12, it is 8, but minus, minus and minus, plus, and we have 8. 3 plus 3, it is an even number, so it is positive here. We have 4 minus minus 4, and it is 0. Is it 0 here? Yes, okay. So now we are ready to make an adjacent matrix. Adjacent matrix. A matrix. This matrix consists of elements of the cofactors here. Consequently, a11 it is 2, a12 minus 10, a13 6, a21 3, a22 3, a23 minus 3, a31 minus 4, a32 8, and the last one element is 0. But don't forget to transpose this matrix. If you remember the transposition of matrices, you have to exchange the rows, these columns. So the first one, column of this matrix, of the transpose matrix, consists of the columns of this internal part. So it is 2 minus internal part 6. Then we have 3, 3 minus 3 here, and minus 4, 8, 0. Okay. So, and the very last thing here we have to define if you want to calculate inverse matrix. It is 1 over the determinant of the A matrix times an adjacent matrix A, and determinant is 1 over 12 times 12 2, 3 minus 4 minus 10, 3, 8, 6 minus 3, 0. 0. There is not 30 here. Zero. So I can put this 1 over 12 into the matrix, and we have 2 over 12, 3 over 12, minus 4 over 12, minus 10 over 12, 3 over 12, 8 over 12, 6 over 12, minus 3 over 12, and 0. Okay, your homework here, home assignment, or individual work, home assignment, check if the result of our calculation, a raised to power minus 1, is really inverse matrix to the A. So I mean, this is our checkpoint here. Yes, we calculated something, but we could do some mistakes or lapses in our calculation or inaccuracy here, and maybe we drop something. So this is the way how we can check is this really the inverse matrix or not. So see you later. Bye bye.